All right, we're live. I guess we should have discussed a little bit on where we want to start first or whatever.
We'll do it live.
All right. Do we want to just start by talking about the book or just trying to...
Yeah, Andrew, why don't you introduce who you are and why you're on here? You got something pretty exciting to announce.
Yeah, thank you.
Let me do the intro first, and then we'll do that. I was just thinking we might prep a little bit first, but
sounds good.
But yeah, I'll just get us kicked off. I think we'll be fine. All right, here goes. Hey, welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey now.
Dave Kimura.
Hey, everyone.
I'm Charles Max Wood from Top End Devs. This week, we have a special guest, and that's Andrew Atkinson. So,
Hi,
Andrew, do you want to introduce yourself?
Yeah, I'd love to. Thank you. My name is Andrew, and I'm a software engineer. And the last few years, I've been really focusing on how to best use Postgres as a database with Ruby on Rails web applications. And most of my career has been doing that for different companies. And I've excited to be here today to talk about a book I've been working on.
Yeah. Do you want to tell us? What prompted the book? Where did that come from?
Yeah, I think probably the main thing was just a desire to kind of, help more people. And to help my own career, help grow my career through impact and that kind of thing. And I felt like a book would be something that could help me do that. It's a work in progress, so we'll see. But I think I felt like from working at a bunch of companies and on a bunch of different teams, and even from my own experience with my own career earlier in my career, I felt like I always lacked kind of like, I could always have benefited from more knowledge of SQL, indexes, database administration, data types, like all sorts of topics. And, I guess I had the opportunity to focus on that more at a couple jobs as a full-time employee. And I just kept finding that it was more and more interesting as I kind of peeled back layers and was really enthusiastic to learn more, and then kind of fit my natural style of wanting to share and teach. And I can tell you more about this, but I was approached after presenting at a conference to whether or not I had interest in writing a book on Postgres. And that's kind of how the whole thing started.
So I want to get one thing, out in the open right off the bat, because I think it's important to talk about. But, please tell me if hey, just go buy the book, if needed. So most of the time, as we as developers create web applications and stuff, it's not the language or framework that's slow. It's not even the database that is slow. It is us as developers that are creating slow queries, slow interactions, and calculations. So what is your opinion on optimizing at the database level or the server side of things versus just writing better code?
Yeah, well, I think, since I'm most experienced as a developer, I can speak more to that side. As I've tried to build out my own Postgres specialization, I've tried to pick up kind of maybe what would have been more DBA skills in the past. So I do have some familiarity with tuning parameters and things like that. But yeah, I agree. I mean, generally, Postgres and other relational databases are general purpose, mechanisms to read and write data to a file system on a host OS, right? And we, as developers, we mostly take them for granted. We just expect that they work because that's their job, is to durably store our data and to make it fast for lots of people accessing the data. And, it actually continues to be super fascinating to me how over decades, there are these two really different paradigms, which are, relational databases and object-oriented programming. Object-oriented programming is not the only programming paradigm, of course, but like with Ruby on Rails, Ruby language and other languages, it's a, maybe the most popular paradigm. So we've got these like object layers and hierarchies that developers are thinking about. And then we have this kind of general purpose database. And for a lot of operations and a lot of scale, it's actually fine. You can just kind of use it without really knowing how it works. But what I found regularly mostly at VC-backed startup companies I've worked for, I've tended to join them kind of at a Series A sort of stage where they're in a scaling mode. They might have a product market fit with their product. And what happens is kind of like, queries that were fine on smaller sized tables with less rows or at smaller levels of concurrency, they start to become problematic. They start to slow down and it affects user experience. And then that's where there's a need to then go a little bit more deeper with your relational database. Like, how does this work? What is actually happening when I run this? What are the queries that are being generated, right? And then what's actually happening within Postgres to fetch the data that my queries need? So I think my general or kind of generic advice is, for most people getting started, I don't think there's, I think I'd love for every Rails developer to buy the book, and even other web app developers.
Mm-hmm.
But I don't think that, if they're just getting started, it's going to be, there's definitely value in there for things like constraints and things that aren't really related to high volume access patterns. But the book is really targeted when you're kind of like scaling up and you need to know how things work a bit more. You need to know about indexes. You need to know about queries that are problematic, things like that. So yeah, I do think overall more of a skew towards the kinds of, needs that an app developer has and their usage of the database and helping them get more out of it.
Yeah, for sure.
Yeah, one thing I was reading through your book. I didn't make it all the way, but I made it a lot of the way. And one thing I really liked, first of all, is you get start everything off with like this sample application, like a ride sharing app, right?
Yep.
And that was great because you could follow along and see like how it would relate, right? All the different optimizations and things. But second, I really loved your recommendation on setting up a performance version of the database where you can just start testing and analyzing queries and poking around various tasks. I thought that was great. I mean, I know a lot of people will have a staging environment, and keeping that, production is definitely a huge issue all by itself. Can probably be its own book.
Yeah.
But you did give some great tips on kind of how to copy over production data from your production data. And there were some really great points about that. And so I'm curious, realistically, is there a huge maintenance burden to adopting something like that, to having that duplicate data and querying it over time? Or is it kind of just taper off after it's already set up?
Yeah, I do think, so there's a whole backstory behind that chapter, which was the original pitched chapter to the publisher. But I did try to produce, at least for one table, I think only, but a way that you could script a process like that, so that if you did have, there's what we didn't do with the book was we didn't really get into how are you actually running Postgres, because it could be a huge number of different ways. But if you can start from a database dump that you could generate with pgdump, or you could have access to snapshots if you're using a cloud provider or something. We tried to provide an example where here's how you would deal with all these tricky nuances with constraints. You can remove foreign key constraints and add them back later, for example, stuff like that. And I do think it would be a pretty significant investment if you build a system like how that chapter describes across a real running production applications database, given it's got dozens of tables. But I'll say that, in my experience, the emphasis of that chapter is on let's make your data safe to work with in a pre-production environment. And what that means is really removing the sensitive customer info and that kind of thing, which isn't really, typically in my experience, it's not a big percentage of the overall app. So the chapter has readers, just kind of using some more obvious stuff like email addresses and things like that you might want to scrub out. Go through and go through each of your tables, find the sensitive data in your database. And then if you focus your efforts just on scrubbing that, you could bring over other table data as is. And then that way, like you said, you've got this production-like set of data you can work with in a pre-prod environment. And if that's all too much, there are other solutions too. I didn't actually get into it in that chapter, but there's some ways you can mask data just on the fly with some Postgres extensions. And one thing, a past company I looked at was there are SaaS providers that offer something similar to what is built in the chapter, where they'll analyze your data and do some scrubbing. So, if you wanted to make a buy approach, you could go that route too. But regardless of how you get there, I do think having some way to have we also considered calling it like a playground, but having some way to test with your real data is great, because you can do a bunch of speculative indexes, you can do a bunch of schema changes, query changes, all kinds of things, and then you can just throw it away and regenerate it all again if you need.
But if we're talking at scale, and if you are taking a dump, sanitizing the user data, that time will also start to, linearly increase as the amount of data increases. I think you run into the same kind of problem if you're trying to do performance testing on a database and you're seeding in data. That can also take a lot of time to generate the data. So if we're, talking about, we're at that point where we're really starting to scale up, do we start getting diminishing returns from pulling down the production database? Because I've worked on some databases that were in the terabytes of data, and to pull that down is just unrealistic.
Right.
But to take a historical snapshot or something would be a lot more feasible when we were much smaller.
Yeah, what I might recommend is the idea, the kind of the scale that the book is targeting to, is I felt comfortable targeting a scale that I've worked with, which is databases that are in the kind of low terabytes range. And maybe you've got, so I think for kind of like modern internet web applications, it's pretty easy to reach a terabyte of data, if the application is successful and has been around for a few years. So what you might want to do, and some of the SaaS offerings do this kind of thing, is you might want to move to sampling at a certain point where, you don't pull every row, but maybe you keep. So this gets into a little bit of a trickier situation, because ultimately you do have this graph of data that applications expect to have. So what you might want to do is look at a way to keep the graph intact with a smaller set of data. I've actually done some work on a separate project for that as well. But yeah, it's true. Like when you have tables that are, gigabytes, like there's just a lot of network movement that takes a lot of time. So I do think having, leveraging, and this again too, by the way, there are other, like I mentioned, there are other solutions that are an alternative to this, where you just do masking on the fly. You don't have as much security for the data at rest, that kind of thing. But, I think it kind of depends on your kind of time and investment trade-offs. So yeah, I'd say that the intention of the book was to help you build, or that chapter was to help you build a scrubbing solution where you might have, 10 to 20 tables where they could range in size they could be in the gigabytes themselves, maybe up to, low tens of gigabytes. And I think you can build a solution using the techniques in that chapter that runs in a reasonable amount of time, that you could run like on a weekly basis, something like that.
Cool. Yeah, and sanitizing data, it's not only important for protecting the user privacy, but also their experience. Because if you have, wanted to just like run your local environment or something, and you pull down that data, sanitize, so you're protecting the user data at rest, but then you've got to also change the API keys for whatever email account you were using, you're testing stuff, sending out stuff to production clients. Yeah, that's a horrible situation, and I've seen that happen, and I've caused that situation in the past, to be honest.
Yeah.
So,
Yeah, it's important. It's important. Yeah, go ahead.
I have a question on this though, because a lot of that data I've started using the active record encryption on it.
Mm-hmm.
And so when I'm sanitizing it, I can't just say, run it across all these fields because they all get encrypted. Or can I? Is there some way around that so that it happens fast? Or do I have to do each one on its own?
I haven't worked with active record encryption, and generally the content in that chapter was unencrypted content, so like plain text.
Okay.
you'd want to scrub. I'm assuming if you could bring your, I would assume if you could bring your encryption keys into your pre-prod environment and decrypt, that might be one option. If you otherwise, I think you might need some mechanism to maybe if you wanted to have separated encryption, you could maybe decrypt and re-encrypt with a different key. If that had a lower security environment, I guess there's.
Well, what I was thinking was more along the lines of I pull the data into my pre-prod environment. Since I have the encryption key on my local machine, of course, I have it in production as well. Right. Then, when I load the app, it's going to show me real customer data.
Right. Yeah. So if you have, the chapter is actually a SQL oriented solution and using like shell scripts and so if you would need Rails or Active Record involved to decrypt the data.
Right.
And then at that point you could invoke SQL from Active Record, I guess, because you need a way to kind of like hook into that process. But yeah, that would be outside of the scope of what we did in the chapter.
Okay.
That being said, yeah, we did where I worked previously, we had database level, field level encryption, and it's a common requirement and a benefit for some kind of security audits and things like that, that you can show individual fields have an extra layer of protection. And so, yeah, it's a good thing to raise awareness about.
I'm also curious, in kind of a high performance Rail or high performance Postgres book, what's different about writing a high performance Postgres book for Rails developers versus just high performance Postgres?
Yeah, it's a good question. I mean, there's certainly a lot of overlap, and part of what inspired me was a book I had read from Greg Smith, it's called Postgres High Performance. Now, it was based on an earlier version of Postgres, but what I found is that, again, going back to that original question, is it was a little more, administrator oriented, without access to a particular code base or a sample app, or maybe like what an application developer might be most concerned about, which I think is commonly kind of queries and indexes and things. So on my kind of Postgres enthusiasm arc, I came across this person named Haki Benita, who is a blogger and presenter in the Postgres space. And Haki first exposed me to the idea of like an application DBA as different from an infrastructure DBA, where the application DBA is going to care more about, this might be obvious, but just in case it's not for folks, they're going to care more about what the application needs and how it works with Postgres. So, queries and indexes and maybe some parameters that are related to queries, or that kind of thing. So, what's different about Rails or even any client application? The application or the book does have a dedicated chapter on Active Record and kind of like, common usages and then more advanced usages. But it's also kind of like not meant to be in a Postgres vacuum. And it's kind of like you're running a Rails app. So of course you want to take advantage of caches and things like that, which are going to be way outside of Postgres, but they're going to be like application level or client level caches. And another question I had for myself in the beginning was, well, what's really different about Rails or Active Record than from some other language or framework, like, for example, Python or Django, or Python and Django, or Laravel and PHP, or that kind of thing. What I decided to do was focus on what I knew best with this and really make it about Ruby on Rails. But I have heard some folks that are from other communities, like they work with other languages and frameworks, that are similar to Ruby on Rails and Ruby. And they've picked up the book and they found it to be valuable. And for example, for Django, it's got a lot of similarities in its ORM with writing migrations, some similarities with multiple databases support. But I don't work with those technologies regularly. And so if I had really kind of cooked up some examples, it might have been fun, but it would have been outside of kind of what I knew best. So since I'd been working with Rails for more than 10 years at different companies, I felt like I'd really try to focus on what do Rails developers care about that use Postgres, that want to, use it. They want to know about all of the features that are available to them and kind of use it as more of a key tool in their overall stack.
Yeah, speaking of that, I did pick up on a lot of the advantages that Postgres has. I work in MySQL all day long, and it's easy to pick up the advantages in Postgres, even from the Rails context from your book. And the a simple example is the returning clause in Postgres, where you can return a record from your insert or something like that.
Yep.
So you can prevent a whole other select query and keep things transactional. I mean, this is just one example of the many that you have in here.
Thank you.
That I think aren't necessarily Rails specific too, right? But just happen to be provided by the Rails framework. And so I'm curious, what was your favorite kind of trick that you've picked up where you just find yourself using it all the time? That's very much Postgres specific.
That's a good question. Well, I would say that I guess I know that other relational databases have query planners, but I would say that I'm still, years into really trying to learn what every line means in a lot of detail. Looking at using the Postgres query planner and giving it all kinds of different queries, or even looking at examples on the internet of other people's queries, and trying to understand all of the information that's available to me in there related to designing better indexes and storage access that's happening, and the different algorithms for different join types and things like that. So it's maybe not as exciting of a feature. I'll throw one more out though, maybe. Part of why it's tricky, I've realized, to answer this question, I've heard this question before in different contexts, is Postgres really prides itself on its level of adherence to the SQL standard. So there's a lot that's it's kind of well, isn't actually a whole lot, I think, that is really Postgres specific, because it does try to adhere highly to SQL standards. And in fact, there are discussions sometimes on the Postgres mailing list about features that really need the support of a standard or a spec before they get implemented in Postgres. So I don't actually know what the support is from other relational databases, but I know in Postgres 16, for example, and there's coverage of this in the book, but there's a new keyword called merge, which is kind of the new way to do an upsert operation, which means either an insert or an update when you don't know what the state of the data is. And you can do that in one command. It's called the merge command. And there's a standard that supports it as well. And the cool thing about that is, it's like another kind of SQL operation we have available, and then it could gain support in the ORMs later by active record or that kind of thing. But yeah, maybe those are two things to consider.
So with your book, I know it's geared towards Postgres, but there is a lot of overlap, in my opinion, between Postgres and MariaDB or MySQL.
Yep.
Can readers benefit if they do use MySQL as their primary database from reading your book? Minus the things that are, Postgres specific.
Yeah, because there really aren't. Actually tried to make even the returning keyword that Valentino mentioned, I actually thought was exclusive to Postgres, but I believe it's supported in SQLite as well. And I think the exclusion constraint is possibly only in Postgres, but I haven't really sat down and went through kind of a blow by blow of what's exclusive to Postgres. There's actually a great resource and another occasional collaborator, Tobias, who runs SQLfordevs.com, that I'll shout out. The emphasis that Tobias has is on kind of like what it sounds. It's SQL for developers for relational databases, whether they use Postgres or MariaDB or MySQL or another relational database. And Tobias has a couple examples on his blog that I noticed where he calls out Postgres exclusive features. And I just don't recall any off the top of my head now, but I remember reading, this is exclusive to Postgres. So I think he did a little of that research. But yeah, to answer your question, kind of side conversation there. Yeah, I hope so. That the intention of, for me, like part of what inspired me to write this book and a book in general is doing something that's going to be useful for a long time period. I'm hoping for like 10 years. Technology changes so quickly, but one of the other inspirational books for me was from pragmatic programmers as well, called SQL Anti-Patterns, SQL Anti-Patterns, which is about 10 years old or maybe even a little more. And I was reading it in the last couple of years and found it, super relevant, and it's, 10 years old. So I think that hopefully I did try to minimize to some extent, really. There's certainly examples of things that are probably going to age poorly, in a year or two, but I think there's a lot of fundamentals like, query performance, for example, being mindful of the actual storage access that's happening, like the IO that's happening. That's not going to really change over time. Like, you want to restrict the query as much as possible to reduce your IO, like regardless of indexes. And there's examples in there of doing that for queries, for indexes. So I do think that there are concepts that will easily translate. And then a lot of the SQL examples in the book, a lot of the book's examples are not in Ruby. They're in SQL or shell scripts. And those things, there's a pretty good chance you can run them as is on another relational database.
Cool. And so what do you think about solid cache and solid queue coming out from Basecamp and now leveraging the database instead of Redis or, whatever other mechanism it's using for caching or queuing up jobs? And how does that, do you think, affect short-term, long-term applications on performance?
Yeah, so that was pretty cool to see because it felt like a bonus, because I was advocating for a similar thing in the last chapter of the book. The last chapter of the book kind of has readers, encourages readers to say, what else can I use Postgres for that I might not be using it for now? Using everything you've learned in the book prior to that point, writing efficient queries, good index design, good schema design that scales well and stuff like that. Maybe you could consider using it for your cache store or for your background job processing and that kind of thing. So when that came out of Rails World this past fall, those projects were announced. Hey, we can use the relational database for more things because of SSDs and because of faster storage access and like operations that we wanted to use an in-memory store for before, we can actually do now with kind of like our boring old relational database. That was awesome. I was like, hey, this is great. This ties right into the book. And yeah, so there is an existing good Postgres open source. I've had the privilege of meeting the creator a bit, Ben, tool called Good Job, and you can run background jobs with Good Job, and it's well used in production and that sort of thing. And then on the caching side, there's a couple of solutions that are showed in the book where you can throw your kind of small bits of data into. You can use a couple tricks like an unlogged table if you're okay with losing that data if Postgres were to crash. If you had a mechanism to rebuild cache data, for example. And you can use tactics like running a separate instance. That might be another Postgres instance. That's your cache instance, for example. And the benefits of doing that are you can still kind of work with the data with SQL, still same like observability, logging, access, those kinds of things. So I think in general, like having background jobs processing, cache entries and that kind of thing, having some extra kind of advocacy around that for using the relational databases is exciting because, like I said, it ties into the book. But I think the latter part of your question was what was the latter part? Is kind of like, what are the implications of that? Or
Yeah, on a and kind of where I was going with this is I tried out solid caching and I'm actually using it on Drift Ruby in production.
oh, cool.
And one of the caches I had, I'd never realized, but it was doing a per user level caching. So it was caching the user ID when it was generating a view. I thought for performance reasons, but what ended up happening was using solid cache gave me visibility into like how much I was actually caching stuff. And after just a week, I had over almost 100,000 cache entries into the table for solid queue, or I'm sorry, solid cache. I'm like, that's way too high. It should be nowhere near that high. So that gave me the opportunity to go back and look at how I was caching and then, that kind of stuff. But if that had happened on a larger application and if it had happened, exponentially more, then, what kind of implications will we be looking at? So would something like solid cache start to degrade the performance of normal queries, reads, and writes? Assuming it's on
Right.
the same database.
Yeah. So for anyone that's not familiar, you can run, whether you're using Postgres or a different database engine or different relational database technology, you can run a database is like a logical grouping, and that runs on a server instance or a host or they're called different things. In Postgres, we typically call it instance. And you could, if you ran, even if you separated out your cache database but it ran on the same instance, then any of that read write activity and IO activity would affect the resource. It would consume resources on that same instance that would contend with the resources for your main applications queries. So you definitely would want to be mindful of the impact on that. For example, with caching, if you had a design, with Postgres, one of its it's one of its more infamous features is how it does multi-version concurrency control, how it does essentially concurrent access, controlling concurrent access to the same rows and tables that are, different clients are accessing. For update and delete operations, the way it works is when those updates and deletes occur, it essentially creates a new immutable version of the change, and it leaves around the old one. And that then is cleaned up later by the vacuum process, which runs automatically. So when this is running in the background, why am I bringing that up now? Because if you have a high churn table with a lot of updates and a lot of deletes, you're going to be, and depending on how you've tuned vacuum, you're going to be triggering vacuum more likely more. And that can take away some resources from your kind of main client query workload. So when you're administering Postgres, you want to be mindful of what's happening behind the scenes to kind of keep the operations running, and then what's happening in the foreground with your client application queries. So for something like caching, what I'd recommend is, if it's completely new, I think it's always a good technique for high scale applications to introduce changes gradually. So maybe you could have, if you had a caching solution that was like, let's say in Redis or a different cache store, you could gradually introduce some of that traffic into your relational solution. Ideally, if you could double write it for a while, and you could kind of see what the operational impact is on your instances. And then you could gradually add more, as opposed to kind of like a full cutover in an uh-oh situation. And then of course, like ideally, if you could run, depending on your scale, this adds a lot of complexity. If you have a big scale application, you might be wanting to run it on a different instance entirely. So it'd be separated both at the database level and at the instance level. And I haven't really looked into solid cache yet, the implementation, but we know that Active Record supports multiple databases, which, by the way, was also one of my inspirations for the book too, is that I think the multiple databases support really opens up, being natively in the framework opens up a lot of use cases for running multiple instances and kind of thinking like of your overall operations as not tied to just one instance, for example. So yeah, you could have, just this one separately scalable instance. Like, let's say you're on a cloud provider, you provision it, you start writing all your cache there. And that way, you have isolation of the compute that's being used for that read and write activity. That's going to be separate from your application's resources, the database that your application is reading and writing to.
Yeah, my understanding with solid cache is that by default, it just holds on to everything that it caches for 90 days and then starts cleaning it up. And so, yeah, after you hit that 90-day threshold, yeah, I don't know what the algorithm is for cleaning it up. I think it just cuts everything off that's older than whatever. Or it hasn't been used since whenever.
Yeah.
But, yeah, and so the implications, at least for the first 90 days, are probably minimal if you're talking about the way that it cleans those things up. I'm using solid cache as well on top end devs. But yeah, I'd be really curious to see what kind of information you could pull from the database, if you evaluate what's in there, what's in that cache. But I could see that as a possible upside to using something like solid cache.
Yeah, and if you're, I think what's really cool about with both caching and background job processing, it sounds like this will be Rails 8, the next major version of Rails, or you need to pull in these gems now. And if you don't have solutions for these, you probably do if you have a in production Rails app. But if you're building a new Rails app, having these in the framework gets you going, with minimal dependencies to start, which I think can help, bring your product to market quickly. And I think it was, Dave, I think you had said that you can leverage your existing observability tools and SQL skills to see what data, if maybe you didn't write the cache store part, but you're on a team where you're maintaining it, you can go and inspect it using SQL. It's going to show up in likely if you're using an APM tool, it's going to show up there. It's going to be a access. And it's not that you couldn't have an APM tool with different data stores, but you're going to have like a lot of, going to reuse the benefits you have for your regular application queries for like a cache store setup. And then, if you want to, there are some techniques in Postgres anyways that, could help you, besides moving to a separate instance, could help you manage that if it's a high growth rate data. You could look at table partitioning. There's a whole chapter in the book on that, where you can create a system. If you do find that you want to kind of cap either the amount of data that you store, you can design a partitioning structure that makes it very efficient to get rid of older data that you don't want any longer. And that could be a good fit for a cache store as well.
Yeah, you can configure solid cache to use multiple databases. So, I don't know if it uses any of those strategies. It'd be interesting to see that built in, or a plugin that lets you do that, right? Where you can set the partitioning to something other than whatever hash key it uses or whatever.
Yep. Yeah, the table partitioning is something that I like to mention to folks, because I think it is a little bit, it's kind of an interesting feature because it's native to Postgres for 6 major versions now. So it's not, you could do, it's what that means is that there's keywords that are built into Postgres. It's well documented. It's tested on each major version, et cetera. But there isn't support for it in active record. And I think generally it's kind of like one of those things where it just goes beyond what the app dev might typically do. And it might be like a DBA sort of thing. But what I found is every Rails app I've worked on, there's always 1 or 2 tables where it would be a good fit, that are kind of like, they're either time oriented, or they could be, you could imagine how you could segment the data up, and how over time some of that data will be more useful and others will be less useful. Like, for example, if you have multiple customers in in a single table, and some of those customers churn, then you're kind of just carrying around row data that's not being accessed anymore, and that kind of thing. And so I do think, table partitioning, it's one of the features that is most exciting and interesting to me, because I think it is so useful and it's kind of underused. It's also more complex. So it's towards the end of the chapters of the book. But yeah, I think it fits with a lot of app scenarios, and it also fits with this cache situation.
Yeah, it's funny. I saw that you gave an example of like archiving older tables or just rows that you just don't need to reference anymore. And I feel like that's a very common scenario, right? Is like, okay, you just have this table that grows and like 90% of the information you don't care about. Like,
Right.
You just need it there for like, for reporting.
Yeah.
Right. And I feel like there's no good mechanism in place like for Rails to like set how you want the table to grow and archive over time. So it's really interesting. I'd be interested in that too, to see where that leads, because I feel like there's like a huge opportunity there, right? Because I don't know of a good way other than just throwing in a data lake and cleaning it up in the background and hoping that you can access everything later.
Right. Yeah.
Right.
Yeah. That's thanks for bringing that up. Yeah. That's been my experience too across different companies and teams I've worked on. Is there's the either we just kind of leave it and it's just a table that gets bigger and bigger forever, and queries slow down and indexes take longer to build, and there's more latency on index maintenance, or maybe they have like a background job that deletes old records once in a while. And that's actually the perfect use case for range partitioning in Postgres. I think for active record to support it, there need to be an equivalent partitioning type in the other supported relational databases, MySQL, and I don't know how this works in SQLite, but assuming it's similar with, because it has a whole different storage model and stuff like that. In theory, though, it could be part of an object relational mapper. Is you could have some kind of like you need a few pieces running at the same time for it to work, though, because with this kind of scenario where we're talking about where you might remove old records, that's usually something that happens through, like, it doesn't happen natively. It needs to be like invoked. So it could be something running. It could be some procedural language code running within Postgres, or it could be an external client. So in the book, readers use the PG slice gem, which is a Ruby gem. And the app for the book, by the way, is public and it's open source on GitHub. And PG slice is included there, so you can kind of practice. But the idea is that after some period of time happens, to actually remove the data, you would need to run a few operations. So you can detach a partition, you can archive the data, and that kind of thing. I think it's possible that could be integrated into the framework, though. And actually, now that we're talking about it, I do remember some discussions about exploring that in a future Rails release. So it'd be interesting. It's like this tension, though, I think, between do everything in Ruby and active record, and like, do we want to leverage these higher powered database features or not?
Yeah, it does seem, though, that we could have some kind of plugin either for the PG gem or active record that, it just basically says, we're going to assume you're using Postgres if you install this gem, and then give us access there. Because I think most of the people I talk to, they don't necessarily want to get into the SQL all that much, and they don't want to go and, fiddle with Postgres on its own. They really do want to manage as much of it as they can in their Rails app. And so, I think it could be interesting to see, hey, there is this power feature in Postgres, and here's the plugin that lets you access it. Mm-hmm. And yeah, if you switch to SQLite, it's either going to no op or it's going to blow up.
Yeah, so I think for readers of, so PG Slice only works with Postgres, but there would be a relatively thin wrapper if you wanted to be able to write Ruby code. Like what PG Slice does is it really just invokes SQL commands that run against Postgres. And the cool thing about table partitioning is that it's declarative like SQL, and that it presents tables to the application as if they're kind of regular tables. So in a sense, you do get that benefit of not having to care too much about the implementation details about how the old rows are removed. And under the covers, what's happening is there's this structure where you have this parent table and you have these child tables underneath it. And so you could imagine a setup from the application level where, again, you don't really need to get into the SQL commands if you have this kind of like programming language level interface that sets up this table structure in the first place. And this is pretty much what PGSlice does, but you could generalize this to other relational databases. Sets up the structure, and then it takes care of writing and reading rows of data that you've described are the kind of range that you want. And then the stuff that's older is just taken care of for you. It's removed in some way. And, for anyone that's listening that wants to try this out a bit, they can do this right now with the rideshare app and with Postgres, and it's all runnable locally. So you can just install Postgres on your local, in my case, Mac OS machine, and install PGSlice and the rideshare app and play around with table partitioning. And then, hopefully from that point, you'll be able to evaluate how you might use it in your production app.
I just looked up PGSlice. I was unfamiliar with it, and it was written by Andrew Kane. I mean, is there anything he hasn't written?
No, he has written everything. Yeah. Yeah. There's a lot of, I've gotten the chance to send a few messages back and forth with Andrew, and there's a lot of things that he works on that are mentioned in the book. And I think, as any longtime Ruby on Rails developer knows, he creates a lot of open source software. And so besides PGSlice, readers also work with PG Hero, which is a cool Postgres open source performance dashboard. And then lately, Andrew's been working on PG Vector, which is helps you turn Postgres into a vector database, and gives you comparable or competitive performance to dedicated vector databases like ChromaDB and Pinecone and some others with Postgres. And it's supported by PG Vector, has been added as a supported extension to a lot of cloud providers. So it's something people can use.
For those who aren't familiar, vector databases are typically used for machine learning and things like that.
Yep.
So I wanted to dive in here to like this advanced usage with extensions, because I've only ever just installed Postgres extension and then just like hope that it continued working.
Oh yeah.
I don't have like too much experience. Like
I identify with this approach,
right?
Yeah. Yeah.
Have you had like any bad experience like installing an extension and then having to maintain that, like having issues with that? Because it does seem like very easy to make an extension of Postgres, and that to me always sets off alarm bells. Like, like this is going to be a pain to upgrade because it's so easy.
Yeah, I think you have better developer instincts than I do sometimes, because I'll just like YOLO myself into those situations, and then I'll realize later, like, oh yeah, this is also software that needs to be upgraded, and that is true. Like you can get into a jam when you do major version upgrades if there's some kind of breaking change. So typically, what I would recommend is for most of the well supported. So most of the things in the book I tried to focus. I've told folks there's about 40, if you add up all the Postgres extensions that are mentioned and Ruby gems outside of Ruby on Rails, with most of these being, I think, I don't know, I guess what the split is, but there's around 40 pieces of software that are, they're all open source. And with the extensions, generally where I've worked, we've used Amazon Web Services, which has this curated smaller set of extensions. And the benefit of that, while it's a smaller set, that means you can't use a lot of extensions, because you can only use what AWS supports. The benefit of that is that AWS has done some vetting of that, and they kind of support that if you're moving to different versions and that kind of thing. So for things like PG cron, for example, is one that's mentioned in the book, or another popular way to do partitioning is with the PG partman extension, or some of the built-in ones that ship with Postgres, like auto explain or PG stat statements. Generally you're not going to have problems going to a new major version of Postgres, but you might need a new version of the extension. So, depending on how you are running Postgres and how it's distributed, that could involve, if you're self-running Postgres, that could involve compiling a new version of the extension. And to do that in production, it would probably be like a cutover situation. and then you need to enable the new version of the extension. So what I found generally is extensions are versioned as well, and usually they publish a change log and that kind of things. You can kind of see like how are they tracking against which major version of Postgres.
Yeah, I actually ran into that recently with Good Job because I was adding it on a much older application that I had, and I didn't realize that I was using Postgres 12. So I had to enable the PG crypto gem. And I was wondering, like, man, why is this not working? Then I went back and saw the migration and his little footnote that Ben had in there. I'm like, oh, so that was the first time where I ever tried using Postgres in a situation where I was just not really familiar, just kind of testing things out. And
Mhm.
then the extensions kind of bit me, but it was an easy resolution, not what you're talking about here.
That's good. Yeah, I mean, it does kind of what the book's philosophy is, that if you know, hopefully by the end of the book, you feel more comfortable as a reader using Postgres as more of a first class part of your stack, like beyond just basic kind of read and write operations. And that does include taking advantage of Postgres's extensibility through its extensions and understanding a bit. That being said, I think there probably could be, and maybe I'll write up a blog post on this, there probably could be more on the life cycle of extensions, but yeah, it is. I think you could consider looking at it like, or like a listener or a possible reader of the book could consider it like, when we do web application development, we work with lots of different things. We also work with front-end technologies that have their own extensibility and their own extensions, mechanisms, and that kind of thing. And Ruby on Rails helps us by letting us build assets and things. But if you've gone through the pain of, managing like node versions and NPM and things like that for full stack Rails apps, I feel like you probably can take on Postgres extensions and that kind of thing. Like, Postgres does have a great, there's lots of great documentation and then support channels and mechanisms as well. I know I'm pretty active in the Postgres community Slack, which is pretty popular. So I can pop in there and ask questions or answer questions. And so that being said, I think it's a little outside of the realm of where a lot of Rails developers hang out, kind of.
Mhm.
But you can get, if you get stuck on an extension upgrade, like there's ways to power through those problems too.
Yeah, I think the Good Job one is a real scenario that people could face. So let's say if I enabled Good Job on my application and it was using Postgres 12, there's that enable PG crypto line that you uncomment. Now you can use it on your Rails app that's using Postgres 12.
That's
Well, if
right.
I were to go and upgrade to Postgres 13, I still have my old migration that has that enable PG crypto extension. So what happens then when I upgrade to Rails or to Postgres 13? Would I need another migration that disables that extension, or what would happen because now it's kind of baked into Postgres 13 and later?
That's right. Yeah. In newer versions, I'm familiar with what you're talking about. And in newer versions of Postgres, you can generate UUIDs values natively, if people didn't know that. And prior to Postgres 13, you needed an extension. There's also another one that's common, like UUID. Well, there's another UUID-OSSP, I think it's called. So if you did a major version upgrade, then you probably would want to, if you didn't have this awareness that you could drop that extension, the way I would approach it would be, by my default way of working would be, well, I need to make sure all of my extensions work on my new target upgrade version. But if I knew that I didn't actually need it, then I could make that part of the upgrade process where it depends. You can do with Postgres upgrades, you can do an in-place upgrade, and there's a built-in mechanism for that. And that's going to work differently than, there's another technique where you can do a cutover, where you can basically restore your data to a new instance running the new major version, and you can kind of cut your application over. And they have different trade-offs with how you test that and how you ensure that you have minimal amounts of downtime and that kind of thing. So I guess I started talking about the path where if you knew you didn't need that extension, and you wanted to rely on the native UUID generation, the way I would approach that is I would want to test my Rails application that depends on that UUID generation. I'd want to test that like on a code branch that tests against the Postgres, the new version, let's say 13, on a CI system or something. So I run my full application test suite and make sure that it's still generating UUIDs and reading them. It's just doing it with a different approach. If I did the in-place upgrade, then what I would probably do is look into the release notes for that extension and see if it's supported with the same version on the new major version of Postgres, which if that was the case, that would be great, because then we wouldn't really need to do anything. If that wasn't the case, then I would see if possibly we could upgrade the extension on the old version first before we did the new major version of Postgres upgrade. And if we could do that, again, there might be like the caveats here are you have to plan out like, you want to test this kind of thing on a separate instance, like a pre-prod instance, and kind of see what the impact is, collect timing and see like what the downtime impact might be. Ideally, you can do it quickly, maybe with very low, 5 minutes, plan it on a weekend or something like that. Upgrade the extension version, make sure it works with your application. And then that way, then it's kind of separated from your Postgres upgrade.
Yeah. Yeah. It's a fine dance.
Yep. Yeah. It's really like the maintenance of applications over time, similar challenges sometimes with Ruby gems that might have like native dependencies or, it's for any kind of long running, but, hopefully successful application that is, providing a lot of value, you're going to run into these upgrade challenges.
So I had an advanced question again, because I noticed, also notes in the book of like creating functions and procedures and things like that. And I found good uses for them in the past. I know you would think,
right? Sorry.
I mean, are they a good idea to do? And maybe like when are they or aren't, right? Like, because I still don't know the answer to that personally. So I'd love some, professional insight here.
Yeah, it's tricky. I mean, I mostly worked with teams that mostly write Ruby. And so like, hey, let's write these procedures in the database or these functions in the database. Like you got to have a pretty compelling, if you have some other senior engineers you're trying to convince why it's better, you have to have some pretty, irrefutable evidence maybe in modern times for why you're not just doing it with the application language. So I think that if you have something that, it's maybe not the most satisfying answer, but for functions, you can write them with just with the SQL language itself. And if you have something that's relatively simple, like i.e. a SQL query you can run outside of the scope of a function, and it's almost like it doesn't need to be tested. Like it's, what's an example? Let me think about an example for a second. But if you have a simple SQL query, or you're using some built-in functions to Postgres, like you're doing some basic transformations, and then you want to kind of combine those. And that's, I think, there's for sure examples of this in the book. Like you combine a few transformations of data with a new custom function that you write, you store it in your app. I think they're fine. I think that they're an alternative to writing relatively straightforward code that you might write in Ruby, but executing within the database. And then what that gives you is possibly, you need to test this on your own use cases, but possibly less, like better performance through reduced IO or reduced network access. So if you have to like pull data to Ruby, do some stuff, write it back in, versus like if you can just send one operation that's, that does a transformation within Postgres and does a write, which I guess I kind of am segueing now into procedures. So procedures are a more advanced form of functions in Postgres. And with procedures, you can get transactional control, which means you can create your own transactions. So you can do like, again, this is, you want to be careful with getting too complex here without having kind of like unit tests and other things which you don't have unless you bring those in as well to Postgres, which there's like PG Tap and there's other solutions. But if you wanted to do something like with a transaction where you fetch some data, write some data, something like that, then again, that could be a reasonable usage for procedures. Not being very specific here, kind of being hand wavy. What the approach I took, I didn't really feel like I could make a strong, these are the situations you should definitely use functions or procedures, and these are the ones you shouldn't. But what that book does is it uses some tools like the Scenic Ruby gem, for example, and I believe some others. The FX Ruby gem, to show developers of Rails applications how they could manage their functions and triggers and procedures, kind of, and treat them more like application code. So you can use those tools to create versions of your functions, for example. And then, as you revise those functions, you can create new versions, and it's all visible with regular old active record migrations, which I thought was pretty cool. So I think that kind of gets you like a halfway measure to making those kind of database only disconnected somewhat functionalities like connected more to your application. And then it's probably going to be up to you and your team to decide if you want to implement certain functionality that way versus at the client level. And I think it kind of comes back to like benchmarking and how valuable it is and that kind of thing.
Cool. Well, we're kind of getting toward the end of our time. One question that I wanted to ask before we wrap up is, so for a long time, it seems like the kind of low-hanging fruit has been just indexes and N+1 queries and stuff like that. Is that still the low-hanging fruit, or is that just kind of something everybody does at this point, and the next level of low-hanging fruit is something else?
Yeah, I felt like there are some people that even say, like, who cares about N+1 queries? Because sometimes, depending on how your application is structured, let me take a step back. So I do think that they're a good entry point into, like, here's a query pattern that is problematic, but it's really like, why is it problematic? And so then I think it's like, well, each query uses up a database connection. Well, what are database connections? Well, they're a finite resource, and there's actually some overhead with establishing new connections. How do we establish new connections? Well, in Active Record, we use the connection pool. What's a connection pool? So it creates this, like, it's a good way to, I think, start to learn about all of the pieces about what's happening from writing Active Record code to that getting turned into a SQL query that's sent over the network, what's happening on Postgres. But I don't think that typically N+1 queries, I don't think that they're pretty well understood, and there's a lot of tools. There's one in the book that are commonly is like, they're well known as an anti-pattern. And so there's a lot of tools that help detect them and even sometimes fix them. So I think that it's a good entry point. And then I think if you're a developer that's like, I got N+1s under control, I think the next place to consider is as far as leveling up with your database skills would be to look at a more advanced query design and really indexes. I think indexes usually at the end of the day are, they're the tool that you have as a developer to make your queries fast and to make your queries low cost as well. So if you can very efficiently, if your application's data that it needs to access can be done very efficiently, you can use up minimal amounts of resources on your instance, and you can have greater scalability.
Cool. All right. Now, one more thing before we get to picks, and that is, thanks for listening to the end of this segment. Now, Andrew worked things out so we can give away a copy of the book.
Yep.
And so what we're going to do is, if you go to rubyrogues.com / what should we call it? Postgres book. It will take you to a place where you can actually enter to win. And it's one of those where you can also share the contest to get more entries and things like that. And so
cool.
we'll run it that way. And we'll make sure that it's up by the time this goes live. And if you've won, then we'll let you know, and we'll let Pragmatic Programmers know, and you'll get a copy of the book in your account. And yeah, I think that's kind of the best way to do that. I've set up a couple of other these for like conference tickets and stuff. So
Awesome. That sounds great.
yeah. So it's a system that works pretty well. So yeah, that's rubyrogues.com/Postgres book. If you can't find it that way, just go to the show notes, and we'll have a link there too, so you can enter to win. And we'll run it for like 2 weeks after the episode goes live, and that way you have plenty of chances to get in and get entered, and then we'll give the book away. And then if you don't win, go buy it. All right. Let's do picks. Valentino, what are your picks?
So I've joined a makerspace, which if you have one in your area, I highly recommend joining. It's just so much fun. So I've been playing with the 3D printers a lot. They have a lot of them. And the Prusa MK4 is just a fantastic machine. Just additive printing layer by layer, and the granularity on it is you can't even see the layers. Even it's so like small, which is to me wild. The first time I used the additive printer, I was like, why would anyone buy one of these? It's just so choppy. But they've come a long way. So definitely recommend that printer for sure.
Awesome. Dave, what are your picks?
So a couple of picks. I'm an idiot, so I accidentally refreshed one of my computers, and I didn't realize that I had all of my Thanksgiving photos on there that I had taken when I was traveling, and so I deleted everything. Luckily, I had a time machine backup that did have them on there, and also checked
Oh, nice.
Backblaze, which also had it backed up there. So back up your data. Use a time machine, get a hard drive or something, back up your data, because wherever you have it stored on isn't guaranteed, and you could either do something dumb like me and delete it, or your computer could crash, get stolen, or whatever. So have good backups. And then speaking of computers, I got this Silverstone case that I absolutely love. So before, I had all my computers just kind of sitting up on my desk and stuff, and I got tired of them sitting up on my desk. I like the desk real estate to just be able to spread out. So I got a half rack that's sitting next to me that have all my audio gear, and now my computers, I put them in a Silverstone case. It's a 4U, so I was able to use all my existing components. I didn't have to get anything new except for the case. So now I have a 25U rack next to me that's sadly already filled. So I don't have any more space to play.
I'll have to check that out. I've been wanting to put a rack in here for all my audio and other equipment. So yeah. I'm going to jump in. I always do a board game pick or a card game pick. This one is, if you're a big fan of Disney, one of the games we got for Christmas is the Disney Chronology game. And basically, you draw a card, you read it to the player to your left, and then it has a month and a year that the thing occurred. So it'll be like, this song from this movie won an Oscar or Academy Award or whatever. I don't know which ones are which, but it won an award, right? And so it was the big song of the year. And then that person, you start with 3 cards in front of you, and you're either picking before all of them, after all of them, or in between 2 of them, right? And so you decide which slot it goes in. If you're right, you get the card, you put it into your chronology, and right the next time you go, you have 4 cards in front of you, and you pick, between 2 or on the ends. If you get it wrong, then the next person around the table gets a shot at it to put it in their chronology. And so sometimes you get lucky, and right, you have 1955 and 1956. And so if there's something right around there, that's hard. But then that you get something that is in the 80s or 90s, and you don't know better than that, you can just put it on the end. So that's nice. But yeah, we had a good time. I live with a bunch of Disney nuts, and so I'll admit to also being a big Disney fan. So it was fun, right, to just go, okay, Steamboat Willie was 1920 something, right? And so you fit it into your chronology and just, see how well you can remember when the things come out. Anyway, Disney Chronology, fun game. A couple of other picks that I have. I'm trying to remember what I picked on JavaScript Jabber just a minute ago. I'm blanking out. My life's been so crazy lately. I think I'm just going to leave it there with that pick. And Andrew, what are your picks?
Yeah, I wasn't familiar with the picks, but I'm going to use context clues here, and I've come up with 2 picks that I think maybe fit the style or the goals of the pick section. So one is imagine that you've been writing a book for like 18 months and you sit at your computer for long hours and your legs are stiff and, you know, maybe you've put on a couple pounds. Well, I got something for you. I'd recommend this. I picked up a walking pad on Amazon for about $200. It's from Eurovo, but I think there's a whole bunch of them. And I've got a standing height desk. So I've had it for about a month now, and I found it's really nice to get some extra steps in during the day. And I found I wasn't sure if I'd be able to, but I can type at about, if I walk at about like 1.5 miles an hour or so, maybe max, I can still kind of type, and it helps me feel a lot better than, you know, extended periods of sitting, is to just get a little bit of steps in. So I think that's been nice. And then my on topic recommendation or pick, I became a subscriber myself to PG Mustard, which is a Postgres query plan visualization and recommendations SaaS product. And there are what PG Mustard tries to do over some free and open source alternatives is give you some recommendations that are a little bit more deeper on your schema design and your index design and that kind of thing. And it's run by a Michael Christofides, it's just a real small operation, and he's become someone I've gotten to know a bit through the Postgres community. So I like to shout it out to recommend that as well. And I've been able to use it to help optimize some queries and index designs.
Awesome. Before we wrap up, where do people find you online?
I'm on Twitter and X at @AndAtke, and I blog at andyatkinson.com. And then I also have a newsletter going for the book at pgrailsbook.com.
Awesome. If you put those links into the chat, then I'll get them over into the comments.
Will do.
And yeah, we'll go ahead and wrap it up here. Thanks for coming, Andy. This was awesome.
Thanks, guys. Yeah, it was great to share this with you, and thanks for having me.
All right. Till next time, folks. Max out.
Talk to you later.
All right. Hang in here for a second while we get all this stuff in the comments. Oh, dang it. I hate it when it does that. You copy it and it says opens in a new tab, which messes up the URL.
Oh, yeah.
So helpful. Yeah, it's funny you did the backups pick because I learned Rails working for an online backup company.
Yeah. Time Machine has saved my butt many, many times.
Oh, yeah.
Hey, Dave, my Apple time capsule died, and so I get the warning about time machines have not been backed up in like a long time. And I like set up Dropbox though a long time ago, so I'm relying on that. But I would like to get time machine backups going again as like another layer. Do you have a easy recommendation for something I can just drop into my network? Or
So you're wanting to do a more of a NAS backup?
well, I was wondering, like, so I had the time capsule, you know, that was the Wi-Fi
Yeah.
and a kind of a NAS sort of or whatever.
Mm-hmm.
Yeah, I guess basically like if I have I think a Netgear, I forgot it's an Asus. I have a Asus Wi-Fi router now, and I was